Ever wonder how a robot could dance, kick a ball, or even do kung fu? It's not just sci-fi. Researchers are making huge strides in teaching humanoid robots to move like humans. But here's the catch. Real-world motion is wildly complex. Robots have to balance, coordinate limbs, and adapt to unpredictable environments. That's where a new breakthrough called GMT comes in. Let's break it down. Traditional robot controllers struggle because they're often designed for specific tasks, like walking or jumping, but can't handle the full range of human-like movements. Think of it like a chef trained only to boil water. They can't sauté, bake, or grill. Plus, real-world data is messy. Imagine trying to learn dance moves from a video where some steps are missing, others are too fast, and the camera shakes. That's the problem researchers faced. Unbalanced data, hardware limits, and partial observability, meaning robots can't see all the info humans take for granted, like subtle environmental changes or body feedback. Enter GMT, short for General Motion Tracking. This isn't just another algorithm, it's a paradigm shift. Imagine training a robot using a giant library of human movements, but instead of forcing it to memorize every step, you teach it to understand the patterns. GMT does this with two smart tricks. First, adaptive sampling. Picture a student learning math. Instead of drilling easy problems over and over, they focus on tricky ones. GMT does the same. It identifies which motions are hard, like a complex dance move or a sudden pivot, and gives them more attention during training. This prevents the robot from getting stuck on easy tasks and ensures it masters the tough stuff. Technically, this is achieved through a reinforcement learning framework that dynamically adjusts training priorities based on motion difficulty metrics, like joint torque demands or trajectory unpredictability. Second, the motion mixture of experts, MOE architecture. Think of it as a team of specialists. Instead of one robot controller trying to do everything, GMT uses multiple experts that each handle specific motion types, like one expert for walking, another for kicking, and another for balancing. These experts are neural networks trained on distinct motion datasets, and they collaborate via a gating mechanism that selects the most relevant expert for a given task. This modular approach allows the robot to switch seamlessly between actions while sharing learned insights, like how balanced strategies from walking can improve stability during a jump. The proof is in the pudding. GMT-enabled robots can now perform a jaw-dropping range of skills: dancing, boxing, high kicks, even squatting with precision. And it's not just simulation. These robots are doing it in the real world. Compared to previous methods, GMT's approach is more efficient, adaptable, and generalizable. For example, in experiments, GMT reduced training time by 40% while achieving a 25% higher success rate in dynamic environments like uneven terrain or sudden obstacles. So what's next? This isn't just about robots doing cool tricks. It's about building machines that can navigate our world as flexibly as we do. Whether it's helping in disaster zones, assisting in healthcare, or just making our daily lives easier, the future of humanoid robots is getting smarter, one motion at a time. Want to see GMT in action? Check out the project page. There's video after video of robots doing things that once seemed impossible. And if you're curious about how this tech could shape the future, hit subscribe. We've got more on robotics, AI, and the science behind the magic.